Hey, good afternoon, Nichols Chemistry. Welcome to the Nichols Chemistry Roadshow. My name is Professor Chad Young. Ada Young is my assistant today, and I want to look today at a little demo with thermal physics. So what I have here are two different objects. They're the same color, they're different weights, and I'm going to have Ada touch them and tell me which one is colder.
Okay, this one's definitely colder.
This one, she said, is definitely colder. The one that is right here is definitely colder, she says. Now, what would you tell me if I said that these two objects have been in the same bag together, sitting next to one another for several days?
I would say that's true.
Okay, it is true. Would you still say that this one's cold?
Yes.
Okay. They've been in the same place, right up next to one another for days and days. That means that these two objects, which have been transferring heat back and forth between one another, are in thermal equilibrium. And when two objects are in thermal equilibrium, would you be surprised if I told you they have the same temperature?
Well, yeah, because I felt it and it felt colder.
Oh, well, let's try. Look, I have an infrared thermometer. Let's see. Ooh. 112? No, she's normal. So I'm going to test this one. I get 76 degrees, and this one, 76 degrees. These two blocks are exactly the same temperature. This is the colder one, and this is the warmer one. Now, I'm going to put some ice on the two blocks, and I want you to think about what might happen to the ice. What will happen to the ice on the, quote, colder block, which we really know is the same temperature, as the warmer block? Which one will melt more quickly? Will the ice melt more quickly here, or will it melt more quickly here? What do you think? The cold or the warm block will melt it?
Well, the warm, because, like, it has to be warm to
Let's
melt.
put it on the warm block. And cameraman, you might need to move the camera. Okay, so there is the ice on the warm block. And now I'm going to put it on the colder block. As you can see, the ice on the colder block is melting at a much faster rate. And the reason is because this material, which happens to be aluminum, has a much higher rate of thermal conductivity. And so it draws the heat out of the ice, causing the ice to melt. That's why it felt colder, because the aluminum, which had a higher rate of thermal conductivity, would draw heat out of your finger. Whereas this material, is plastic, has a very low rate of thermal conductivity, so it doesn't hardly draw any heat at all.
Wow.
Yeah, wow. Have a great day.